Okay, so what did we find?
That it did work.
It did work, okay. So, what's the pattern?
The Fibonacci numbers, so the longs are the Fibonacci numbers. And then
The longs are Fibonacci starting from 1, and the mediums are Fibonacci from 0.
Okay. And what would it mean if we found a pentagon whose side lengths were integers?
That would mean that there's some amount of mediums that adds up to be an integer.
Ah, okay, very good. It would mean some amount of mediums adds up to be an
Because
integer.
the longs are already, we can say they're already integers.
All right, we could start and say the longs were already integers. And so some amount of the mediums would always would be an integer. Okay? How do you think? So that was a good observation. It doesn't have to be the first one. You put that small pentagon in the middle. It doesn't have to be the first one, whose diagonal is a long plus a medium. It doesn't have to be that one, but it could be another one. It could be a different one.
Yeah.
Okay? So what do you think happens next in the argument?
So we have to somehow prove that the mediums, like we could say there's a value of mediums that they're integer, that the amount of mediums is an integer.
Okay, so we have something where the side length is an integer and the diagonal is an integer. Okay? So what do you think happens next?
Well,
We could maybe set up a ratio again.
Okay.
let's see. They're both integers.
Well, how did it work the last time? What did we do?
So we said that these two integers were the smallest integers that worked.
Aha. So we would find something that was the smallest set of integers that worked.
So we could do the same here.
Okay. So maybe we'll go back to the whiteboard and we'll take a look there.
Okay.